Okay, these notes are entitled Balancing Chemical Equations. I didn't write that very well. Okay, so you're going to learn to balance equations. Basically, to balance them, they have to follow the law of conservation of mass, which states that matter cannot be created nor destroyed, which means you have to have the same number of each element on each side of the equation. So, if you have, let's say we've got hydrogen plus oxygen giving you water, you have to have the same amount of hydrogen and the same amount of oxygens on the left side of the equation as you do on the right side of the equation. Okay, let's go to the next slide. Oops. Okay, so let's look at the H2 plus O2. So we have H2 plus O2 yields H2O. Now, just like we did in the activity today, I'm going to draw some pictures. So we're going to have an H and an H here. Then we're going to have an O and an O. And over here, oh, I'm going to draw like a little line down the middle. And over here we have an H and two H's and an O for water. Now, our H's are balanced, but our O's are not. Now, in order to add another O to the right-hand side, we can't just add O. We got to add an O with our two H's. We have to add water. When you add that other water molecule, you've just now added two more H's, which means we have to put more H's over here. So now if we count, we've got 4 H's and 2 O's on the left side, 4 H's and 2 O's on the right. So it's a 2 with a 2 here. Now, drawing pictures really does help, but I'm going to teach you guys how to multiply and divide so that you can count using just the numbers without using the pictures. Okay, so let's try another one. We got Fe, oops, well, it would help if my pencil would work. So we got Fe plus O2 yields Fe2O3. Now, with this one, we're going to try drawing pictures first, and then the next one we might try and do without the pictures, just to see if we can do it. So I'm going to draw my Fe, and then my Fe2O3. Okay, now it looks like I need to add at least one more Fe on the left, but I'm going to wait till last, because I can add as many Fe's as I need to. So since that thing's by itself, I'm going to leave the Fe on the reactant side to the last thing. Let's look at our oxygens. We have 2 on the left and 3 on the right. And I got to somehow get them to be the same number. Kind of reminds me of fractions. 1/2 and 1/3. If you were going to add together 1/2 and 1/3, you need to do it in 6. So let's add another. We have to add more oxygens on the right hand side, so we might as well just add a whole nother, well, we have to add a whole nother molecule. I now have 6 H's on this side, or 6 O's I mean. Okay? 6 oxygens on this side. So it's not too hard now because all I have to do is have 3 of the O2s, and I've also got 6 O's. Fe-wise, I have 4 Fe's here on the right hand side, on the product side. Well, all I got to do is add 3 more. So I now have 4 Fe's. So it looks like I'm balanced. So let's go ahead and put our numbers in there. So we've got 4 Fe's, we've got 3 O2s, and 2 Fe2O3s. Okay, we're going to use this exact same example, only instead of drawing pictures, I'm going to show you with a chart and numbers. So let's look at our 2H2 plus O2 yields 2H2O. Now, I had already drawn the pictures, so let's learn how to do this multiplication-wise. There are 2 H2s. That means it's 2 times 2 gives you 4 H's. There are 2, this tells you how many O's. There are 2 O's here. Over here, this 2, that means there's 2 of the H2O's, so that's 4 H's, and then 2 of the O's. So it's 2 times 1. You're kind of distributing that too. When it's a big number in front of a whole molecule, that big number goes to every single element. You're distributing it, kind of like in math. Okay? So let's try another one. Okay, we're going to learn how to use a T-chart. Now, the only problem with this particular program I'm using, I can't erase. So I'm going to have to keep drawing T-charts. You don't have to draw these charts. You just erase the numbers in the middle. Okay? And then change the numbers. Actually, what I'll do is I'll make room to scribble. I don't usually make myself have enough room to scribble, but I'm going to have to on this one because it doesn't let me erase properly. So we're going to do F, E, and O. Okay, in the beginning, we have 1 here and 2 here, and we have 2 and 3. Now, I see a 2, 3 situation, kind of like I was describing in the last slide. If you have 2 of one thing and 3 of another, and you need to get them to balance out, you've got to find a common denominator, or common number between the two. And a common number between 2 and 3 is going to be 6. So we're going to change, like this right here. If we change it to a 6, that means we're multiplying it by 2. So we got to move that 2 up there. Well, when we do that, this changes to 4. Over on the right hand, or left hand side, to change this to a 6, we're putting a 3 here. Well, it's pretty easy at this point. All we have to do to get, because we have to get this a 4, we have to put a 4 here. So oops, I guess I should cross out my 1 first. Okay? So it's 4, 3, and 2. And if we look at our chart, it is completely the same. It's perfect. Okay? So we are now balanced. That's how you balance with a chart. So let's try it again. Okay, let's try this one. So this time we're going to do reactants and products. And as I said, since I can't erase, I'm going to be forced to cross out. So I got P's and O's. Okay, so on the left-hand side, we've got 4 P's and 2 O's, but over here we have 2 and 5. Well, the P's are easy. All I have to do is put a 2 in front of that P, and then I've got them balanced. But so let's look at our even-odd situation. Down here we have 2 O's and 5 O's. So we are actually going to double this. We need to make it 5 an even number. Okay, so we've got 10 there and 4 there. Well, 10 oxygens does not balance out with the oxygens on the left-hand side. So all we're going to do to make that 10 is put a 5 here. And then we have it. So now it looks like we're totally even. We got 4 P's, 4 P's, 10 O's, and 10 O's. So pretty easy. Let's try one that's a little harder. Okay, this time we've got potassium chlorate decomposes to form potassium chloride and oxygen. So one time we're going to put the reactants and products. Okay, and we have K and Cl, and I got to add a third one, and O. Okay, so on the left hand side we have 1 K, 1 Cl, and 3 O's. Do you see that? There's no, what are they called? Subscripts. Yeah, subscripts. Can't think today. No subscripts by the K and the Cl. That means there's at least one. Okay, on the right hand side there's 1 K, 1 Cl, and only 2 O's. Okay, well, we do have to get the O's balanced first. Okay, they're the even odd situation. So once again, we're going to double this up the top to give that 6, and put a 3 here to give that 6. Well, now that we did that, we've got to change the number of K's because we now have 2 K's and 2 Cl's. Well, I don't know about you guys, but I think it's pretty simple. Just put a 2 in front of there, and we get 2 and 2. And now it looks like everything matches. So we are now balanced. Pretty easy, huh? Okay. We're going to look at the balancing of methane, the combustion of methane. Now, we did this one in our activity yesterday with the little pictures. I'm going to show you how to do it T-chart wise, and then I'm going to show you another harder one, and then I'm going to give you the rules for balancing all hydrocarbon combustion reactions. So we're going to put our R and P here. Okay, in our chart. This one only has C's, H's, and O's. Okay, now we have 1C, 4H, 2 O's, 1C, 2H, and 3 O's. Okay, now this is the one time we are not going to balance the O's first, because the O's are in 2 different substances on the right-hand side and only 1 substance on the left. Okay, so what we're actually going to do, we start with H's. Any kind of combustion reaction, you start with the C's, then the H's, and then the O's. So the order to balance: C's, then H's, and then O's. Okay, now sometimes you have to double, sometimes not, but let's just go with C's, then H's, then O's. Okay, looks like the C's are balanced. So the C's are balanced, so we're going to leave them alone. H's are not, however. I need 2 more H's, so I'm going to put a 2 here. That gives me 4 H's. Well, when I do that, that gives me 4 O's here and 2 O's here. So that gives me 6 O's. Well, now I need 6 O's on the right hand or left hand side. So I put a 3 there and I have a 6. And we are now balanced. Okay? So let's try one that's a little harder than this. Okay, whoops, you know what? I got to make this correction first. It's C2H6. Sorry about that. Okay, so we're going to balance this one. This one's a little bit harder to balance. So we're going to do our reactants and products. I know my chart's a little messy, but who cares? C's, H's, and O's. Now remember, we're doing this in the order of C, H, and O. That's why I kind of write it like that. So we have 2, we have 6, and 2, 1, 2, and 3. Okay, well, let's balance the C's first. Since we have 2 on the left, we're going to have to put a 2 here. Okay, so that gives us a 2 here. Now let's balance the H's. So H, we have a 6 there, so we need 3 in front of here to make that a 6. Okay, now let's count our O's. So we have 3 O's and 4 O's. Oh, well, how can we do that? We have 2. So we now have 7. So now we have 7 and 2. Crapola. Looks like we got to double everything. Okay, so we have to double everything, and I mean double every number that's up on that board. Well, first let's get what that would be. This would have to be a 3.5 by that O2, correct? So we can't have a half. So all the numbers that are up there now, in fact, I'll go put a 1 there, we're going to double everything, but the oxygens we're going to leave to last, the O2s. We're going to double everything. Because of this 7, we have to double everything. So I got to take my little eraser, erase the 1, I'll erase the 2, and erase the 3, and we're going to have to double it. So this is now a 6, a 4, and a 2. Well, now we're going to have to redraw this. So now we have 4 here, 4 here. We have 12 here, 12 here. Now let's recount. We're going to recount our oxygens. So we have 6 O's here and 8 O's here. Well, 8 plus 6 is 14. So we now have 14 O's here. Now it's easy. We just stick a 7. Okay? That's kind of difficult. But if you follow my little rules, then it's not so difficult. So let me write down those rules. Okay, we're going to call these rules for balancing. I'm going to put CXHY, combustion reactions. In other words, any time you have a CH compound that only has C's and H's, and you're reacting it with O2, combustion means you're reacting with O2, you follow these rules. Okay? Now, you have to look at the number of C's and the number of H's. Okay? So, if you have well, actually, you just look at the number of H's. It doesn't matter about the number of C's. You always look at the H's. The number of H's is 2 times an odd number, oops, not and, 2 times an odd number, for example, 6, 10, 5, 7, 14, etc. So basically, if you divide it by half and it's an odd number, you must double the CXHY compound. Huh? What are you talking about? For example, go on to the next slide. Okay, let's look. So if it's C2H6, then you have C4H10, C6H14, C8H, let's see, 16, 17, 18. Okay, basically your number of carbons is even, and 1/2 the number of H is odd. Then you must double. So you're going to start out with a 2, 2, 2, and 2 in the equation. Otherwise, you're going to have to do what we just did in that last example, where you're going to have an odd number of oxygen and you're going to have to double it anyway. So it's really just kind of easier putting the 2 in the front first. Now, when there's an oxygen in there, you can't do that. You got to go back to the normal way. So, for example, if it's C, let's say CH4O, okay? That's something different. You just have to go back to the other way we were doing it, okay? And you might have to double, you might not, depending. So if there's an O in it, this does not count. So the rule does not apply. So it's only if you have just C's and just H's in it. Okay? So let's try one. Let's try a little harder one. Okay. Now if we look at the first one, C2H4, the number of carbons is even, but half the number of hydrogens is not. Okay, it's not odd. So it's an even number. So we can just balance it the normal way. I'm going to go quickly through this. I want you to try and do this yourself first. So turn this off, okay? See if you can balance it and then turn it back on, and I will have the correct answer for you. And I'll show you how I do it. Okay, so basically I do the C's first. So there's 2 C's on the left. I'm going to put a 2 on the right. There's 4 H's on the left. I'm going to put 2 on the right. Now I'm going to count my number of O's. So I got 4 O's and 2 O's. That gives me 6 O's, so it's a 3. So that's your answer. So hopefully you got that answer. Now if you look at number 2, guess what? C's are even, and half of 14 is a 7. So I know to put a 2 there right away before I even start. Now I want you to try and balance it. So turn the thing off for a second, try to balance it, and then I'm going to put the numbers up there. Okay, so let's go ahead and do this. So now I have 12 C's, 12 C's. I have 2 times 14, which is 28. So I'm going to put a 14 here to give me 28 H's. Count the number of O's. So I get 24 here and 14. 24 and 14 is 38. Half of 38. Don't do this in my head very well. So it's 15 plus 4 is 19. There you go. Okay, so it's as easy as that. Yeah, these numbers can get pretty high in here. Okay, so let me give you a couple of practice problems. Actually, at this point in time, you should be able to do the lesson 12 one. So if you still have lesson 12, try to do those. Those will be your practice problems. Well, I guess I will see you tomorrow, and we'll be balancing all day tomorrow. Bye.